Alright, I want to talk about section 10.5, surface area of triangular prisms. And this video is going to be very similar to the previous video where we were talking about rectangular prisms, but this time I'm going to look at a triangle version of it. So first let's draw that triangle, that triangular prism. Looks like this. And we have the part that's behind. And the idea, again, is that we're going to be finding the surface area. So that means I want kind of what's on the side here that I can see, as well as what's on the sides that are kind of all around behind it. And just like last time, the easiest way to do this is to turn it into a net and look at the measurements that we have when it is kind of all laying flat, because it becomes much easier for us to find the surface area when we do that. So let's draw out the net of what this triangular prism would look like. I have these three center rectangles, and then attached to some of the rectangles I'm going to have the end and that little triangle bit. And you can see here that if I were to fold it all up, it could definitely turn into that triangular prism that we were looking at before. Now let's look at how we would find the area for this particular triangle. Now for this one, let's pretend that the measurements are like this. We have the height of our triangle, and the height is going to be, let me draw it in, I should have drawn this a little bit bigger. This is going to be 8, that's going to be 6 centimeters, sorry. And we also have this side here, which is going to be 8 centimeters. That's going to be the base of our triangle. Now in this case we also need to know a couple of other measurements. I also need to know that this side of my triangle here is 10 centimeters, as well as the length of the whole side of my rectangle, and this is going to be 17 centimeters. And just like before, I'm going to be totaling up the area of each of these three shapes and adding them all up. And then we're going to take a look at how that happened and then create a formula based on that, so that we don't have to do this every single time, because it would take forever if we had to do that. So first let's take a look at the two triangles. So my area is really going to be my surface area of my triangular prism is going to be triangle 1 plus triangle 2 plus rectangle 1 plus rectangle 2 plus rectangle 3. And if I were to label them, I could see that this would be my little triangle 1, triangle 2, rectangle 1, rectangle 2, and rectangle 3. Alright, so let's take a look and see what we can do. Well, our triangles are going to be easy to start off with. My formula for an area of a triangle, the area of a triangle is equal to 1/2 base times height. So in this case, I can use that for my triangles, and my area of a rectangle is length times width. That's all that we've got. Okay, let's look at these two triangles. My first triangle is going to be base. My base is 8 times 6, but it's 1/2 times 8 times 6, plus, if I draw a little arrow for how I got to these things, triangle 2 is going to be base times height. Now, this triangle doesn't have any labels to it, but because it's a triangular prism, I know that these two triangles are congruent, because otherwise the lines wouldn't be straight. So this triangle here is going to be exactly the same. It's going to have a base of 6 and a height of 6 and a base of 8. So I can again say 1/2 times 8 times 6. Okay, now let's look at our rectangles and figure out what these would all be. This first rectangle here looks like it's 17 long, so it's definitely going to be 17 times, let me move this over a little bit, this dimension on this triangle, on this rectangle here, is going to be 8 centimeters. Looking at rectangle 2, now rectangle 2 is going to be different, because not all the rectangles have to be exactly the same. Now the length is certainly the same, it's still 17, but this measurement here, draw this, is different. Because this one, if I were to wrap it up along the side of my triangle, I can see that the length here is actually going to be 10 because it needs to be the same size as these two lengths of my triangle. So it's going to be slightly different. So this time it's going to be 17 times 10 plus then my last triangle, which is going to be wrapping around the final side of my triangle, or the last rectangle, which will be wrapping around the final side. So it's going to be 17 times 10 again. Okay, let me get my phone so I can do some calculating, and we can figure out what all of this is going to be equal to. Okay, some things to notice immediately. It's interesting that these first two are exactly the same. We're going to use that to our advantage in a minute when we build our own formula. But let's look at eight times 6 times 0.5. It's going to give us 24 plus, this is exactly the same, 24, plus 17 times 8, 17 times 8, which is 136, plus 17 times 10, which is 170, plus 170. And if I add all of this up, 24 plus 136 plus 170 plus 170, it's going to give us our total area of 524. But I don't want to have to do this for every single problem. So let's take a look at a formula that we can use that's going to make this much easier. First of all, we have two triangles. So let's look at the area of two triangles. First of all, my area of one triangle is equal to 1/2 base times height. And since I know these triangles are going to be the same, I can just add them together. So that's 1/2 base times height plus 1/2 base times height. And if I add these two together, all I get is 1 base times height, or base times height. So if I'm building my formula down here, my surface area of a triangular prism, to get the area of the triangles, it's just going to be base times height, because I have two triangles, so it works out that way. But I'm going to need to add in the rectangle that I've got going for me here. The way that I'm going to do this is, notice when I was doing my rectangles, is that each time I did my rectangle, I was always multiplying by 17 each time. Sometimes the second number changed, but not always. So what I'm going to do is I'm going to use the distributive property to pull out all of these 17s out into the front. So I'm going to call that my length. So I'm just going to multiply the length times the sum of all of the sides. So that's the width 1 plus width 2 plus width 3. Let me make sure that's how they wrote it in their formula. They wrote it a little bit different. They wrote it like this. Surface area of a triangular prism is equal to base times height plus side 1 plus side 2, plus side 3 times the length, basically. So you need to make sure that this number is the dimension of your triangular prism that doesn't change throughout. That's kind of the key for using this formula, because I would not want to use 10 for this, because the 10 is 10 twice, but then it's an 8. What I actually want is this long dimension. That's going to be the one that I'm multiplying the other pieces with. Either way, these both formulas are pretty much the same thing. You can see that I just called the widths 3 separate things, and these I called the sides 3 separate things. Let's take a look at how I can use this to find out the area of the triangular prism that I used above. First, I'm going to write out my formula, because I always like to start that way. Surface area of a triangular prism equals base times height plus length, and I'm going to use the one that I made because I'm partial to the things that I do. Width 1 plus width 2 plus width 3. Okay? Base times height. We have 6 times 8. That's going to be the total area of both of my triangles. Now I'm going to take the length. The length is this long side, 17 times, and I'm going to add up all 3 of my other sides. I have a 10, and an 8. 10 plus 10 plus 8. And there we go. I should be able to solve it. 6 times 8 is 48. right? Yeah, good thing. Doubted myself there. And then I have 17 times 28. I can't do that one in my head, unfortunately. 17 times 28 is 476. 48 and 476. 476. Oops, probably should have been doing this on here, sorry. 476 plus 48 is 524. Good thing, because that's what we got earlier. But notice this way is going to be much easier than our other way, and this is the way that I want you to be solving it. If you'd like to do your drawings and seeing where the different dimensions go, you're welcome to do that. But this is the way that's going to make it a little bit easier and make it spending less time to solve. All right, here's our area, and go ahead and good luck.